All right. Hi, everyone. I'd like to welcome you to today's event in a new series we're calling Privacy Infra. So today we have the opportunity to share 2 hours of tech talks focused on privacy engineering projects. Again, my name is Ben Brook, and I'm Transcend's co-founder and CEO. And I'm here to kick things off this morning with Charles Kim from our team, who will moderate today. So before we get into the presentations, and because this is only our second privacy event of the series, I wanted to give a little more context on what we're hoping to achieve here. So if Transcend is a new name to you, we founded Transcend in 2017 with the vision of putting users everywhere in control over their data. And from the start, we really wanted to focus on engineering first solutions to solving this problem. And as an engineering-centric company, we really wanted to create something just for engineers working on privacy infrastructure projects, so we could come together and share knowledge and learn from each other. We also want this to be as two-way as possible, especially in these virtual times. So we encourage everyone to use the Q&A button and the raise hand button as we go. And we'd love to hear from you afterwards. So if you'd like to present at a future event, or if you have requests for topics you want to hear about, we really want to showcase a diverse mix of privacy projects from different industries and applications. So you can email us at privacy_infra@transcend.io or visit transcend.io/privacy_infra on the web. So at this point, I'm going to hand off to our moderator for today, Charles Kim. And of course, please do reach out if you have any feedback. Over to you, Charles.
Great, thanks, Ben. My name's Charles, head of sales here at Transcend. Glad to have everyone here today. So I'll be the moderator, as Ben mentioned, for this event and the Q&A sessions that will take place for the next 2 hours across this exciting lineup of topics and speakers. And so we got 3 great presentations today that cover a gamut of topics, starting from privacy infrastructure, from consent management to privacy design. So here's a quick agenda as a preview for our time together. First up, we got Uber's Roche Janken, who will walk us through how the ride-sharing platform built an end-to-end consent platform. Then after that, we'll have Kevin O'Gorman, who joins us from the Freedom of the Press Foundation, who will deep dive into using QubesOS for secure applications. We'll then take a short break just after 11 a.m. Pacific, and then Ben will just jump back on to highlight a couple of open source privacy projects Transcend is working on that we'd love to share with this group. And our final speaker today, last but certainly not least, we'll hear from George Rosamond, who's a CTO and co-founder of ClearOPS, to share some ways companies can better honor privacy through design decisions. And this should come as no surprise to anyone who's spent more than enough time on Zoom in the last few months, but we do want to ensure that we encourage healthy two-way conversation around today's event. So if you do have any questions for any speakers today, there's 2 ways you can interact, either using the Q&A button, which will go ahead and directly flag it to me. I'll go ahead and then ask to the speakers. Or one thing I'll actually encourage to this group is during the time when we got questions after each presentation, feel free to use the raise hand button. So what we'll do is then we'll go ahead and unmute your mic. You can ask your questions directly and we can get to your question. The chat feature, by the way, is also there to open the conversation between everyone as we go. But as always, please do keep the conversation respectful. With that, I want to pass the mic to our first speaker today, Roche Janken. Roche is a senior software engineer on the technical privacy team at Uber. She has been at Uber for 28 years in dog years, or just shy of 4.5 years in human terms. In that time, she's designed, implemented, and maintained Uber's legal consent collection services, extended and maintained their user data deletion stack, and she built and maintained original privacy.uber.com. And she has also listed this in her bio when she's not working, which I think we can all sympathize with at this point, basically doing anything to keep her chin up during this very not ideal year. And today she's going to dig into some of that background at Uber by delving into what it takes to build an end-to-end consent platform. So Roche, over to you.
Yes, hi everybody. Thanks, I'm really happy to be here. I'm Roche. I'm gonna share my screen now so you can see some beautiful artful slides. Somebody want to give me a thumb up that they're seeing my screen? No thumbs. 1 thumb, great, that'll do. So great, I'm here to talk about privacy as a service, building an end-to-end consent platform. A bit about me before we begin. I really like lunch. I am, as Charles said, a senior software engineer at Uber. People like to use sporty nature photos, but this is my true favorite activity, which is taking a nap on my partner with my dogs. And I think that's enough intro. Let's get into the good stuff. This is what we're going to talk about. Why do we build privacy platforms, the end-to-end architecture of the consent service, and some things that we learned while building it and maintaining it. I'm going to keep this part short since I think a lot of folks on the call probably don't need to be convinced that we build privacy platforms for good reasons. But just in case you need to convince anybody else, here are some things that we like to think about. We want to make privacy really easy. So if privacy engineering takes responsibility for core privacy services, we can provide proper tools for our users, mostly feature teams or customer teams, you'll hear me call them. We can reduce the eng load for feature teams, and we can incentivize adoption and prioritization. So an analogy that I like to use is back in the 1990s when I was a young person. I remember going to the supermarket with my mom with these bags of sticky, disgusting cans and bottles for recycling. We would go to the machine, we'd wait in line, we'd like put the recycling in the thing, then we get the voucher, we spend it. Lot of overhead, right? And now we have this amazing curbside recycling, makes it really easy to do the right thing, just put the can in the can and it kind of just takes care of itself. So we want to be the curbside recycling of platforms here on the technical privacy team at Uber. We want to make it really easy. The other reason we want to build privacy platforms is to utilize expertise. So in the same way that you would expect a team or a suite of teams to handle payments or handle maps, right? We want a team that handles privacy. We have the depth of knowledge to implement various privacy requirements in a consistent and auditable manner. And another really important piece of that is we have relationships with legal and policy. So folks know how to get to us, we know how to get to them, and we're pretty familiar with some of the compliance requirements so that I know when a decision is above my pay grade, right? If I'm not quite sure how to interpret something, I know who to go to, and I'm not gonna kind of try to do it myself. The last thing I'll mention is that it's possible to standardize when you have these privacy platforms. So we can implement user data protection in a unified way. We can commit to our stakeholders, this is what we do, and this is the metadata we have about it. We can say it with confidence. And the same information is in the same format. We'll talk about that a little more when we get into the consent side. The stakeholders know what they're going to get, they know how to find us, and we have processes for them to work with us effectively. So these are some reasons that we have an amazing technical privacy team at Uber, and let's get into the consent service. So when I am talking to feature teams, this is what I tell them to help them understand when they need to get consent. If you're collecting new data or using existing data for a new purpose, get consent. Yeah. Here is our basic consent flow. This slide is definitely Cliff Notes. The functionality of consents is, I think, maybe a little bit more straightforward than some of our other privacy platforms because basically it is a RESTful microservice. It's just like a lot of other RESTful microservices at Uber, except rather than storing trips or payments, we are storing consent and copy. One thing, again, that makes this, another thing that makes this different from other privacy platforms that our team owns, like deletion and export, is the SLA for consents is a lot tighter, right? So for export, when you hit that export me my data button, we tell the user, give us 30 days. For consents, obviously we need to keep things snappy. We have to focus on keeping things low latency and highly available. And you know, this is, we're not joking around about this because we're in the onboarding flow and the core trip flow. And at Uber, you don't mess with the onboarding flow or the core trip flow, downtime is bad, right? So we have to make sure that this is, you know, up to par, high availability. All right, that's a little bit of background, but let's talk about our basic consent flow. So starting from the top, I'm gonna keep on using the example here of Uber Smells is our feature. We are now collecting smell data. It's very important to smell data from our users. It's new data, so we need to get compliance. And you know, get compliance meaning, has the user seen this copy and agreed to it? So if yes, we can proceed on to the feature. If no, we make a call to the backend to get our locale copy. Locale copy in this moment refers to the words that are legally binding, that are translated into the language that the user has set as their language. Yeah, we display the locale copy on the screen. They say yes, they say no. Either way, we want to store what they say. If they say yes, we proceed on to the feature. That's our little green light. And if they say no, we don't. So all these little purple boxes are calls from the front end to the back end. This is, again, a little bit high level. Sometimes we bundle them, or we do fun stuff, but well, we can ask me about that fun stuff in the Q&A if you'd like to hear how fun it is. Let's talk about the consents architecture. And again, this is a little bit of a simplification. Consents was designed with flexibility in mind. So a lot of our customer teams have their own flows. We have found, and maybe you have found as well, that people have opinions, especially when those people are engineers. And so we don't want to tell them how to build their features or how to build their flows. We just want to provide them with this consent service that they can use that has all of these amazing features that should be very simple for them to integrate with. Yeah. So let me kind of just walk you through this diagram. On the left side, we have our little purple person, and this purple person is using any one of the apps, the front ends that Uber has. Maybe they're using the Rider app, the Driver app, the Eats app, the Fleet Manager app. The apps just go on and on. But we built this mobile consent library that is able to be shared between apps. And the primary reason that we built this mobile consent library is because it provides client-side caching. This is really important for a global company like Uber, because we can't predict the availability, the network availability in the countries that our customers are based in. And we don't want to mess with the onboarding flow. We don't want to mess with the trip flow. We don't want to mess with anybody's flow. All right, so we want to be able to cache the information on the client side and send the data back to the consent service when users are connected. Continuing on to our right, Consents is a Go service. It is built on top of Glue, which is a Uber web scaffold built to standardize coding patterns across the Uber environment. We're going to talk a little bit more about Glue later. So just kind of put a pin in it, as they say. And we have a database. The database is a Cassandra database with a DOSA wrapper. DOSA is an open source database abstraction that Uber has built to make it easier for full stack engineers like myself to use amazing database technologies like Cassandra without having to worry too much about how it is deployed in the Uber environment. Yeah, and then if you look to the right of the consent service, we have the localization service. This is the primary dependency of the consent service, and we thought about rolling our own, to be honest, but localization is a hard enough problem as it is, and Uber has, I think, a fairly sophisticated or at least functional solution. So why take on something that we don't have to? We have this dependency. The localization service has a localization store. That's sort of the high level architecture. I'll note here that we don't officially support a UI layer, but another team built an awesome sort of UI consent modal that many teams have used across different features. That's very plug and play. So again, trying to make it easy for the users to use consents. And then we have this little dotted line section here that says customer service in the little box. That's kind of back to my first point that we were building consents with flexibility in mind. So some future teams will decide to bundle several payloads into one sort of RPC call. There's no reason for them not to do that. We want them to do their features like they want to do them. So this is just an example of maybe bundling several RPC calls and having their service be in the middle between the front end and our consent service. All right, onwards we go. Entity hierarchy. So these are the entities that are in our consent service, sort of different legal entities, and this is the hierarchy and the relationships between them. I think this is maybe the most complex piece of the consent service. And I'm gonna just kind of talk you through why it's so complex, and then maybe if you have a better idea about how to make it less complex, you can tell me in the Q&A, because I've always dreamed that there's like a more beautiful, elegant way to do it, but it's never quite revealed itself to me. So Uber smells. We have our feature, right? Uber smells. And I don't know what else I want to say about it. It's a feature. It's the thing that is on the other side of the consent, the thing that you get to if you've consented. That's a little bit legally complicated. We can talk about that more in the Q&A as well. Beneath our feature, we have a disclosure, and the disclosure exists because we want to provide an easy way to collect reconsent from our users. Those of you who work in app-based companies or who have to deal with the Apple App Store or the Google App Store will know that making changes in the app can be quite a lengthy process. We don't really want to wait to do all of that if, say, we need different consent from our users, different text, different data types. We want to just be able to create a new disclosure which automatically triggers reconsent. Below our disclosure, we have our disclosure versions, and these have metadata about the consent, including the data types and the uses. It's a object, and one day we hope to use those data types and uses for maybe some per field consents, but nobody's really asked for that yet. So why build something that nobody needs? I hear that they call that over engineering. Beneath our disclosure versions, we have our locale copy. That is what is stored, if you remember the previous slide, in the localization service. And our locale copy is the actual legal text that's written by lawyers. It's always backwards compatible. So 1.0.1 is just a small change from 1.0.0. And if you look in the leftist box down there with our territories, our copy that is translated into multiple languages is a exact translation. So if territory 1 has different sort of functional consent requirements from territory 2, those are different disclosures. These are literally like, do we have somebody in California who speaks Spanish? Well, we need to make sure they can read their consent in Spanish. So that's our entity hierarchy. Like I said, tell me if you can think of a beautiful, elegant solution to that. Let's talk about some lessons learned from building this consent service. The first lesson I will share with you is to be flexible, otherwise known as see no evil, hear no evil, and speak no evil. So here's an example of when flexibility really came through for the win. In order to avoid sharing customer data with third parties, this is an Uber Eats scenario, Uber Eats conducts direct marketing on behalf of restaurant partners. So restaurant partners can go to a UI and say, Uber, please send this person who bought a pizza yesterday a coupon for a pizza today. The restaurateur-restaurant relationship is unique and it is identified by a UUID, but it is not technically a user. However, we do need to collect consent from this restaurateur to say, you consent to use this UI to send this direct marketing, la-ti-da. I don't even read the consents, I just build a service. So, you know, a lot of services, it's a common practice in engineering to validate input. So we would be like checking to make sure that that restaurateur-restaurant relationship identified by a UUID as a user. We don't do that because we don't care. We just know that this is an entity that we need to collect consent related to. And by being flexible, we were able to serve their use case, the Eats team, give them all of these awesome features that are associated with the consents platform, and to not ask them to make any weird, hacky changes. My next takeaway for you is to welcome contributions. So we want to make it really easy for our internal customers to contribute to our platform. If you recall, I mentioned that we use this glue, which is this Uber web scaffold, and one of the main reasons we do that is that we want other engineers to be able to put up pull requests to the consent service. An example of that is we had a feature team who was asking us for deferred consents. So if you imagine, you know, I consent to Uber smells, yes, no, ask me again later. Ask me again later is the deferred consent, and it is a user experience concept rather than a legal one. So a deferred consent from a legal perspective is not consent, it is non-consenting. But we did want to, you know, expand our scope a little bit from being purely legal so that we could better serve these customers who probably wouldn't have used our service if they had to track a deferred state elsewhere. Because we had used glue, it was really easy for us to say, sure, you want this deferred consent? I understand what you're trying to do. Please go ahead and do it. And later another team actually added deferred count so that when users said, ask me again later, that modal wouldn't pop up over and over again indefinitely, which we all know is a little bit annoying from all of those accept cookies things, right? So again, another team contributed, and all, you know, current and future users of the consents platform were able to benefit. The magic of software engineering. Last thing for you to take away from this is to be proactive. So we decided it was really important to integrate into key systems before being asked. Thus, if you recall the mobile consent library, as a regulated company, Uber is required to share certain data with local government agencies. Although this use case is already covered by the privacy policy, we wanted to really optimize for user experience by providing additional notice. We already had our consent service and our mobile consent library in action, so it was really easy for the product team to pop that extra, beautiful consent modal in place when they knew that they were going to collect a little bit of extra data, even though it was already covered by the privacy policy. We wanted to, just make it really easy to do the right thing, to make sure that our users understood what data we were collecting and using, and to help the feature team get their product out the door. So those are some lessons learned, and that's the consent platform in 21 minutes or less. I'm really excited to hear all of your questions. I think I'll stop sharing my screen now.
Thanks, Roche. I'll go ahead and field a few questions that came through. I'll start off. Appreciate the effort not to dictate flow to other engineering or product teams, but what was the approach like for mandating onboarding for this service with feature teams?
Yeah, so you're saying, like, how do we get people to use our service?
Exactly. What's the magic number you use?
That's a really great question. So we have a PIA process at Uber, and that process is part of getting an ERD or a technical proposal approved. And if a team needs to collect consent because the PIA reviewer said so, then they need to collect consent because the PIA reviewer said so, because Uber is like a grown-up company where we have to play by the rules and do the right thing. And so knowing that that requirement is non-negotiable, my experience has been that feature teams are pretty excited to do less work and use the consent service, because onboarding is, well, it could certainly be faster. It's pretty fast, and it's certainly faster than building and maintaining your own consent flow forever. Does that answer your question?
Yeah, no, that's really good. Sprinkled throughout your presentation were like some services that are using the consent platform. Do you mind just walking through other types of services? You mentioned Uber Eats, but would love to know. Yeah.
Well, I do my best to forget all of the details of every consent as soon as it's onboarded, so that my brain doesn't run out of space. We are in, like I said, the onboarding flow. So when a user agrees to those first T's and C's, we have that recorded in our consent service. We have some, gosh, you know what? Now that I'm thinking about it, I don't even know if I'm allowed to say all these things. So my answer is, if you really want to know, you should email me, and then I'll make sure I can tell you before I don't know, say something that I'm not supposed to say. Sorry.
Fair answer. It's fine. Fair answer. Curious to know, you mentioned a lot of flexibility. The question I have here is, how does the platform handle policy changes?
Yeah, I'm assuming by policy changes, you mean like changes to what we are collecting from a legal perspective. And that is why we have that whole entity hierarchy with the beautiful tree and all those data types and use cases. Basically, we use semantic versioning to make sure that changes are backwards compatible, and if they're not, we create a new version and we get reconsent from the users, and that's definitely happened before, and it works the way we hoped it did. So that was great. Love when that happens. If I didn't answer a part of your question, just ask a follow-up question.
Yep, for sure, of course. Couple more that just kind of we're fielding in. Has the consent service helped with requests and requirements from external auditors? Assuming you can say so. Smiley
Has
face.
the consent service helped with requests
and requirements from external
auditors? That's a great question. Let me just think about that before I answer.
Yeah.
I think that what I haven't seen is an auditor actually asking us to prove that a user has consented to a thing. Although we could, and we did build the service with that requirement in mind. I think more so it is not a proof, it is having something like this is like the sign of a mature privacy program and a mature privacy team. And the fact that we're doing it, I think probably fulfills some requests from regulators as opposed to actually having to like go back and spit the data back at them, if that is coming through.
Another question, any lessons learned from keeping this critical service running 24/7?
Yeah, great question. Well, I will say that we have just a lot of really great tooling at Uber that's designed to keep things up and going 24/7, you know, using Glue, using Go, using our monitoring and alerting systems, using DOSO. We use these things because they're known to be reliable, and we don't want to go down, just like nobody at Uber wants to go down. So I can't, you know, have good tooling. Have good tooling that all the engineers can use is a good lesson learned. I think that's all I have to say about that.
Cool. No, you're good. Just a couple more that came in. Any design decisions you would have done differently if you have the time machine?
Yeah, so when we first kicked it up, if you remember that beautiful graph of all of the entity hierarchies, our onboarding flow involved like a bunch of scripts to create each entity separately and then associating the different entities with one another. And that was error prone and manual and not fun at all for anybody who had to do it. And, you know, probably like a year into the service existing, we, you know, improved it. But, you know, in that year before we improved it, I probably spent like way too long doing those manual onboarding steps. And we really should have made that process better sooner.
Awesome.
Yeah, I also think that there's some concepts that I didn't touch on about territory granularity and like where a consent applies to, like if it's for California or the US or just Los Angeles. And it's a concept that we've noticed it's kind of hard for our customers to wrap their heads around. So I think documenting that a little bit better, practicing explaining it, probably should like made a cool video about it, would have been a good idea as well, because we've had a couple of we've had feature teams come to us a little bit confused, like why is this behavior not what I expect?
Can you give an
yeah.
an example of that in terms of the confusion from the customers?
Yeah, sure. So let's say we have a consent Uber Smells that applies only to California, and we have a user who is in not California, anywhere but California. I believe, if I remember correctly, the consent service, when called for like getting the locale copy for that user, returns an error. It says, yo, you sent me a bad request. And our users are confused. They're like, why are we getting these errors? Everything is right, but it's just because the user is in the wrong place. Then so the consent doesn't apply to them. Yeah. It's a little tricky. And again, if anybody has great ideas for how to make it less tricky, you should always just send them right to me, rjanky@uber.com.
Awesome. We got one in the chat. It says, hi, Roche. Are there different retention periods for consent at Uber? Example, consent that expires. If so, how does the platform manage that?
Yeah, that's a great question. I think at some point, the short answer is at this point, we don't do that as far as I remember. It has been a few months since I've worked on this service, so things may have changed. Things at Uber tend to change quickly. At the time that I was working on it, we didn't have expiring consents, but there is no reason that we couldn't implement that. And that's also something that we can implement that our customer teams can implement on the client side. They can, you know, get the consent for the user and be like, yo, that's too old. Actually, we need to get it again, which might be happening. Like I said, see no evil, hear no evil, and speak no evil.
I think we just got a question about, I think this is in reference to deferring the consent based on like UI. So how much of the product development cycle revolves around user experience conversations? Have you noticed any measurable impact by focusing on UX and consent or other features?
Can you just say that question again?
Yeah, it's a mouthful. Let me just say that really slowly. How much of the product development cycle revolves around user experience conversations? And then like a tack-on question was, have you noticed any impact, any measurable impact by focusing on UX and consent?
Yeah, the answer to the second question is not as far as I know. The answer to the first question is, I would say the consent was born out of a legal requirement, and I don't think that there's a lot of like pizzazz and originality in like a consent UI besides like having one that has words on it that are easy for a user to understand, and you know, making it really clear that they know what they're agreeing to. That being said, when we've made changes since fulfilling those original product requirements that mostly came from legal, it's been at the request of customer teams or feature teams. And so they kind of have their own product design life cycle, and I don't know how much time they're spending thinking about making a really great consent experience. If they come to us like with a compelling pitch, we say, please go ahead and build it yourself, or occasionally like we will help you. I hope that answers your question.
That's good. Got another question about open source projects. You mentioned a few that were contributions from other teams. The question is there any general pattern that can be refactored out of the service and open sourced?
Yeah, that's another great question. I guess you could open source the entity hierarchy pattern, and then I could get actual pull requests for ways to make it more elegant. I think, you know, the rest of it is, like I said, it's just a RESTful microservice. And, you know, that is, you know, I don't know that us open sourcing that would be really helpful to anybody, since each company has really their own environment with its own, each environment is its own special snowflake.
Cool. Roche, thank you so much for the presentation and for answering all the questions straight in a row. Awesome.
I love to meet people who like privacy, so find me on the internet if you like to just, you know, we would like have coffee. We don't do coffee anymore, so we can have like tea and Zoom or lunch.
What was your email again that folks can reach out to?
I'll put it in the chat. How about that?
That'd be great.
All right.
Thank you, Roche. Next up, we're going to hear from the Freedom of the Press Foundation's Kevin O'Gorman. Kevin is Foundation's newsroom support engineer, and his involvement in digital security stems from his time working in various roles actually in media organizations, including the Canadian Broadcasting Corporation and the Globe and Mail, where he led security workshops for journalists and worked with the foundation to implement the first Canadian SecureDrop instance. Today, Kevin will be diving deep into how QubesOS can be used as a toolkit for secure applications. I'll go ahead and pass it over to you, Kevin.
Hey all, my name's Kevin O'Gorman, and as Charles said, I work with the Freedom of the Press Foundation, a nonprofit organization whose mission is to protect, defend, and empower public interest journalism in the 21st century. Our work includes advocacy with projects like the US Press Freedom Tracker, and we also do an awful lot of digital security training for newsrooms and media organizations. And we develop open source software projects, including SecureDrop, an advanced whistleblowing system. SecureDrop is the motivation behind, though not exactly the subject of my talk today. And it's also, I think, a bit of an odd one out in this meetup series, in that it provides anonymity, not privacy, and for a relatively small set of users instead of at scale. But there's still an awful lot of technology overlap on the engineering side. So for instance, at the last meetup, it was interesting to hear about Penumbra, as that would be a great addition to the SecureDrop source experience. So I'm going to talk about FPS work on a new SecureDrop workstation using Qubes, a secure operating system based on the Zen hypervisor. In the process, I'll also talk about some of the features that makes Qubes a compelling platform for building your own secure applications. So let me just share some screens. That's the one. Share. Looking good? All good? Okay. Okay, so in case you're not familiar with it, SecureDrop is an open source whistleblower submission system that media organizations can use to securely communicate with anonymous sources. It uses Tor for all its network traffic to minimize sources' communications metadata, and it also encrypts all incoming communications using GPG, keeping the decryption key on a dedicated air-gapped workstation. Journalists interact with the system using the Tails operating system, a Debian-based Linux distribution that's optimized for anonymity and also uses Tor by default. We also recommend that sources use Tails, but we don't really have any visibility into what they do, so we can't really enforce that. SecureDrop was originally created by Aaron Swartz and is now managed as an ongoing open source project by the FPF. So it's used by a whole bunch of media and activist organizations worldwide, around 70 that we know of, especially by those concerned with issues like national security reporting or large-scale corruption. One thing that's important to note about SecureDrop, each organization is responsible for hosting its own instance, and FPF has no visibility into any submissions or any activity. This gives the system as a whole a good basic level of resiliency. There's no central hosting service to attack, and bringing down one instance isn't going to affect the others. So let's talk a bit about how it works. There we go. Each instance consists of two servers, an application server and a monitor server, hidden behind a hardware firewall. The application server hosts the SecureDrop application itself, and the monitor server acts as an intrusion detection system for the entire instance. All incoming connections are blocked at the firewall. So unlike a typical web server that supports kind of incoming requests via port 80 or port 443, the application server makes outgoing connections to the Tor network, and all communications happen via Tor onion services. A source uses the Tor browser to connect to a publicly advertised source interface in order to submit messages and documents, and those submissions are GPG encrypted as they're received. So next, a journalist would use a Tails-based workstation called a journalist workstation to connect to a separate authenticated onion service and download any encrypted submissions. They can't actually read them on the journalist workstation, and this is because the corresponding private key is not available there. Instead, they have to copy the submissions to a transfer device, ideally read-only media like a CD-ROM, but in practice, most likely a USB stick. They then take that transfer device to a secure viewing station, yet another Tails-based workstation. This is an air-gapped workstation. Its networking hardware has been removed or physically disabled. The secure viewing station contains the decryption key that they need. The journalist uses that to decrypt the submissions, and from there can share them with other members of their team, either in hard copy or via another USB. If they want to reply to a source, they have to go back to the journalist workstation. They can't do any network operations from the air-gapped secure viewing station. So the security of submissions relies heavily on keeping that decryption key secure. The air gap in the current system gives us a strong level of confidence that it can't be compromised by network-based attacks. So, as designed, SecureDrop has a whole bunch of good things going for it. First off, the use of Tor coupled with the air-gapped viewing station makes it very hard to identify sources or to compromise their communications, even for well-resourced adversaries. The system can be built with consumer-grade hardware. Ongoing maintenance requires basic Linux administration skills, and even non-technical journalists can be trained in the use of Tails enough to get by. This puts the system within reach of even smaller, poorly resourced organizations. It also uses tried and true technologies like Tor and GPG. There's no hand-rolled crypto as part of the system, and those main system components have been around for ages and are very well maintained. But over time, it's become clear that it has disadvantages too. Sources and journalists can make mistakes in their communications that put them at risk. For example, a source might reach out via another means in addition to SecureDrop, thereby potentially exposing themselves. Or a journalist might share files without removing metadata that could identify their sources. Then you have basically the usability of the system. Because of the dual workstation, retrieving and decrypting submissions is time intensive, which is kind of an impediment to source conversations. The secure viewing station itself is also vulnerable to malware and malicious submissions, as it does have some storage that persists across reboots in order to store that GPG key. The exfiltration is kind of difficult thanks to the air gap. But even if it's not affected, other less secure workstations down the line could be infected by malware submitted via SecureDrop. So If we were to build a new version of the workstation, some of the things that we'd like to see would be, first of all, we'd like it to have better protections against malicious submissions. We'd like it to be faster and easier for journalists to use. And we absolutely want to keep the existing security properties of the system. So with this in mind, the FPF went to work. Prototyping began on a next generation SecureDrop Workstation around mid-2017. The project passed its first initial third-party audit a year or so later, and it's been under development since, which leads us to the current day. FPF is currently running a pilot for a new SecureDrop Workstation with a few select media organizations. It combines the Journalist Workstation and Secure Viewing Station into a single hardware device while continuing to protect the decryption key. It has a single GUI user interface or a GUI client that handles all of the submission workflows I was talking about earlier, presenting those in a chat-like interface that's familiar to journalists. And it also opens submitted documents in single-use isolated environments containing any potentially malicious submissions. So these systems these improvements make the system a lot more straightforward for journalists. Pilot users are reporting that checking submissions takes only a few minutes compared to an hour or more with the classic version of SecureDrop. Next up, I'm going to just show it off, assuming the gods of video embedding cooperate. So here we go. Fingers crossed. Is that working? Come on, YouTube. Okay, here we go. So this is basically the login interface. The journalist logs in using the same credentials as they would for the classic journalist interface. And this is the main interface that they see. Source code names to the left and conversations to the right. The client is automatically syncing its state with the application server over Tor, and a new source will pop up if there are any there. Their messages are automatically encrypted. Taking a look at the conversation, they've included a document. So let's just download that. That again is automatically decrypted. And now let's view it. Basically, a toast message should pop up in a minute. There it goes. An isolated environment is being spawned to view it. I'm going to take the next 30 seconds or so to take a bit of a drink of water. So I can't wait to see what this is, as I would really like information for navigating 2020. And here we go. The environment has been created, and now the application. Oh, great. It's a cat poster. That's useful. Okay, so we better reply to the source just so they know that we received it. Here we go. And away it goes. Okay, so that took slightly under 2 minutes all told, which isn't particularly great for the average chat client, but is a vast improvement over the process involving 2 Tails workstations and physical data transfers and manual GPG decryption. So how did we actually manage to replicate the classic workflow securely within a single device? Well, we added one new technology to the mix, and that technology is Qubes. Qubes is a secure operating system built on top of the Zen Type 1 hypervisor. It's developed by the QubesOS project. Version 1.0 was released in 2012, I believe, and it's currently at version 4.0.3. Its fundamental design principle is that all software is flawed and ultimately subject to compromise. So it adopts the approach of security by isolation. Using Qubes, untrusted applications can be run in isolated virtual machines on top of the Zen hypervisor. Security-minded folk around the world use it on the daily to protect their communications and to work with sensitive or potentially harmful data. But it's also a very good, powerful toolkit for building security-focused applications. I'm going to cover just some of its features that we use to build the SecureDrop Workstation, but I'd encourage you to visit the Qubes offsite to find more, or find out more, or even to try running it for yourself. So let's dive in here. Going back to the classic workflow, we had the journalist workstation and the SecureDrop viewing station, or the secure viewing station. Qubes allows us to replace this with a single workstation running a collection of VMs that provide the same functionality, more ease of use, and better protection against malware. So this is what it looks like under the hood. This is a simplified view of the virtual machine architecture backing up the client that you just saw. Obviously, there's a lot going on here, so I'm not going to get into complete detail on it, but we do have a white paper describing the system, and all of our project code is available on GitHub if you really want to dive in. Instead, I'm going to talk about some of the salient features of Qubes that are actually in play here. First up, isolation. The Xen hypervisor isolates hosted VMs from each other pretty effectively. This type of isolation is key, for example, to cloud providers' ability to provide virtual servers without, basically customers being able to view each other's data. Qubes uses the same technology, so to isolate VMs running untrusted applications on the same desktop. So let's consider the process of downloading and decrypting a submission from the point of view of the VMs. First off, we need to think about networking. The only VM in Qubes with direct network access is a system VM called sysnet. All others must use a network provider VM. Sysnet is obviously the first of the potential network providers, but in general, people don't use that. Instead, they use a chain of network providers. So for example, there's another system, our system VM called sysfirewall. Chained to sysnet, you can use it to provide global firewall rules for all of your VMs. Or if you want to use Tor transparently in your VMs, you can use the sysunix system VM, which again derives its network from sysfirewall, which derives its network from sysnet. And using this, you can have a Tor gateway without your app or without your actual application VM having to know anything about Tor. So how do we use this within the context of the workstation? Within the workstation's collections of VMs, only a single one, SD-Proxy, has network access via a Tor gateway called SDUnix, which again basically goes through the firewall and then to the system or the sysnet VM. This is used to communicate with the application server to basically talk to the API there. The GUI client itself is running on a separate VM and communicates with SD-Proxy in order to basically make requests of the application server. It has no network access itself as to none of the other VMs in the system. But that raises the question of how does SD-app actually manage to talk to SD-Proxy if all VMs are isolated from each other? So let's talk about that. So VMs and Qubes are isolated from each other, but Qubes allows for inter-VM communication using the qrexec RPC framework. This runs on the administration VM, which is a privileged VM within Qubes called DOM0, which in turn mediates communications between VMs via the Xen hypervisor. So this is basically an RPC framework for VMs to talk to each other. Qubes allows you to define RPC policies for the various communication types you can actually use. So for example, you can define which VM can share files with which other VM. You can define which ones are allowed to copy and paste between each other. And you can do more interesting things like basically control access to GPG keys stored on like a secure VM from other VMs. So using these kind of RPC policies, you can further isolate system components from each other and control the flow of data within your application. So obviously we use this pretty heavily within the workstation. So let's just take a look at a couple of cases here. So when SD-app makes its request to SD-Proxy, it makes it via qrexec. And SD-Proxy retrieves the submission requested over Tor, passing it back to SD-app in the same way. Then SD-app has to decrypt it. It doesn't have a copy of the decryption key in much the same way as the journalist workstation doesn't have a copy of the decryption key. Instead, it has to make a request of the SD-GPG VM, which is the virtual machine within the system that does keep that decryption key. So it makes another qrexec request or a request via qrexec to SD-GPG to actually decrypt the file. So once retrieved and decrypted, how do we open the file securely? This brings us to the last feature that I want to touch on real quick. And that is disposable VMs or DispVMs. So the virtual machines that users typically do their work on are called app VMs. They're cloned from templates, inheriting a base operating system, but with their own persistent storage for like user data or special configuration. DispVMs are similar to that in that they also inherit their base configuration and then have their own storage. But the difference is that their user storage doesn't persist between reboots. Instead, a disposable VM is created as needed for a single use and then destroyed along with all of its storage when it's shut down. This was the reason for the delay when we opened the cat poster. A whole new virtual machine was being created for it, and then destroyed when we closed the viewer. So going back to the example, having downloaded and decrypted the document, it's time to open it. Instead of opening it within the SDApp VM, which could expose the client to, or basically to any malware within that submission, a whole new disposable VM is created and the file is passed over to be opened there. This protects SDApp and the system in general against malicious files. Even if a malicious submission manages to get code execution on the DispVM, it would still need to defeat Zen's VM isolation to affect the rest of the system. So now the document has been downloaded, decrypted, and viewed, all while maintaining system security. I'm hoping it was something cool and not a cat poster. So we're already looking at future additions to the workstation's capabilities after this pilot phase. For example, it currently supports export to USB devices and document printing, just like classic SecureDrop did from the SVS. But Qubes makes it possible for us to look at networked export options as well, such as sharing files over Signal or using Onion Share over the Tor network. We can also add VMs to the journalist workflow to do more interesting things. So for example, we could have a VM to remove or to basically redact metadata from submissions, or we could have one to scan for malware. The toolkit that Qubes provides lets us add features like this with a reasonable expectation of security. Okay, that is pretty much my quick tour of Qubes. So if anyone has any questions, feel free to let me know. All of our repos, as I mentioned, are available on GitHub at the address shown. The QubesOS project is also basically, or this is their address there. And as we make heavy use of Tor, and it's very important, it's always worth giving a shout out to the Tor project. So that's it for me.
Thanks, Kevin. Appreciate the presentation here. We'll reserve the next couple minutes to just ask a few questions that we're getting from the audience. I'll go ahead and just kind of kick it off and just fire it your way. First question is, does the workstation rely solely on VM isolation for security?
It does not. Obviously, you know, on the classic app or on the SecureDrop servers, we're already using stuff like AppArmor to basically like minimize kind of code execution. We're using stuff like a qrexec built kernel to actually, to basically provide a hardened kernel. And we've continued those over to the virtual machines that are used, or basically are used in Qubes. So you would actually taking a defensive in-depth approach, you would have to get through each one of those before you actually would even get to the point of looking to be able to jump through or to break Zen isolation and jump to another VM.
Awesome. Second question is, does having independent instances of SecureDrop bring any challenges when fixing vulnerabilities in the code?
Yes. So we do actually have an app server where we push out basically releases to, or where we push out basically pretty frequent updates to the SecureDrop application server code itself. Basically usually on like an integer multiple of the tails and kind of Tor release frequency, like release cadence. And those pretty much happen automatically, as we have set our servers are set up to basically check nightly to see if there are any kind of updates to the application or basically any updates to the base operating system that they use. We can't really take this approach with workstations. So let me just check the question here. So we can't really take this approach with workstations because we don't really have that same visibility into the Tails workstations. So we do actually have like GUI updaters and so forth that are triggered and like prompt users to update when they actually do go in there. The situation is actually slightly better in Qubes because we can actually have a network connection there and we can actually get it to check for updates in much the same way that the servers do. So whenever basically a journalist starts a new session with the client, the system will first of all check to see if there are security updates available and prompt them to basically to apply it. So basically that way we can either push out our scheduled updates, or if we have hot fixes to deal with specific vulnerabilities, then we can push those out too.
Awesome. Next question is, how do you automate environment setup in Qubes?
So Qubes actually present, or all of this, the environment provisioning is actually done from the administration VM that I mentioned, John 0. And Qubes makes available the salt stack provisioning system for actually doing that. So you can basically set up VMs, set up all of your qrexec policies within that. There's also an Ansible plugin that you can use to do the same thing. Again, that would run in DOM0. It requires you to actually make some updates to the stock DOM0, which we kind of tend to discourage folk from doing. So in general, salt stack is the way to go.
Got it. Got a couple more in the Q&A. Is it possible to test this out in a virtualized environment?
Well, the whole thing is a virtualized environment. Some folk have actually managed to get Qubes running in basically VMware type environments, but it would not be something that I would recommend. It would probably be better off to basically use kind of a dedicated machine if you actually did want to try out the system. So basically any relatively modern kind of laptop that supports kind of virtualization or Intel virtualization extensions and has probably 16 gig or more of memory because you are spawning a lot of VMs would be the way to go.
Got it. Got it. Got a couple of questions on the chat side, and feel free to decline some of these questions if you're not in a position to answer them. But question I got: are there known hacking attempts against SecureDrop?
Mm-hmm. So there are. I think one of the most interesting ones was actually something that a security reacher actually kind of did, sort of semi in the open, where they actually tried to exfiltrate a part of the private key by pushing out for example, like a Python script as a submission that actually looked like a document. So when journalists opened it, it actually ran the little Python script that basically converted part of the private key into a QR code and then encouraged journalists to actually basically scan that QR code to retrieve secrets. Had they actually done so, what it would actually have done is basically telegraph back to this, back to this researcher what the actual private key was. So that is the example of the kind of thing that we face basically on the classic kind of air gap station. In terms of hacking attempts against Qubes itself, it's still too early to say what kind of attacks are out there. The good thing about Qubes is that the team is very, very diligent about tracking basically base vulnerabilities in Zen and basically staying on top of those. So we're hoping that the system will actually maintain, as I said, a reasonable level of security.
Are there any plans for SecureDrop if anti-encryption laws get passed in the US, such as Earn It?
Move to Canada. Sure. That is kind of an interesting question. I mean, obviously the system depends very heavily on kind of like the availability of encryption tools. And I think that's one of the reasons that FPF also has a very strong kind of advocacy role. Like basically if there are bad laws being made like that, it's just as important to try and fix those bad laws as it is to fix flaws in software. So I think that's probably the angle of attack that we would take in that scenario.
Cool. Switching gears a little bit, I got a question on the, I got an interesting question. I think, are there any specific usability factors or use cases that you consider for a user base of journalists with varying levels of technical experience?
That kind of is a good question. So for the SecureDrop workstation, or for the new workstation itself, we've actually taken the approach of doing an awful lot of kind of user experience testing, like front loading that with it. So everything that we're doing has been based around those kind of experiences. I think the most important thing you can do is not actually make assumptions, but really just test your kind of design decisions with a whole range of users first before actually really proceeding too far down the line of actually, solidifying stuff into code. So I don't know if that's really a great answer, but I would say that there are going to be an awful lot of people basically with different skills, and it's really important to actually speak to those people rather than basically make assumptions about what their abilities will be.
Cool. A couple more before we close this time out. What was the most challenging part of the architecture and installation?
That's a good question. So let's see. I don't know, or I wasn't actually a part of the organization for the initial kind of prototyping. I think one of the early decisions I think that was made we're probably revisiting now was basically around kind of the base templates that we use for the actual system. We went very, very complex with that. Like every single VM type had its own base template. And that's good in terms of being able to very, clearly lock down the properties and lock down the applications that are stored in each VM. but where it kind of fails once you actually see the system in use is that it really like increases the cycle of those updates that I was talking about previously. Like they take a long time because you have to update every template in the background before you can actually do any further updates. So I think that was one of the decisions that people would probably spend an awful lot of time on, and now it looks like we are having to revisit it. But that's part of the experience of developing stuff with, you know, operating systems from the future, which is kind of how I sometimes like to think of Qubes.
Awesome, Kevin. Last one for you. If you had to start from scratch again to build it again, is there anything you would change?
I don't know. Again, apart from that templating decision, I don't really know that I would. And again, I'm going just one person on the team and not even one of the principal architects for it. So if you're, I think we're pretty happy with the design that we have so far. Obviously, again, this all depends on basically the results of audits and so forth. So the system was audited in 2018 and it came back pretty well, or it came back with no critical errors there. We're hoping to basically get another audit of the system, you know, post-pilot, just to basically make sure that we're still on the right track. But I don't think there's anything really critical about the design that would change at this point.
Awesome. Well, Kevin, thanks for the presentation and thanks for answering all these questions.
No problem.
Awesome. Well, go ahead and take a short break for a quick 5-minute break. So that means we'll come back, reconvene at 11:10. After the break, we'll hear from Ben Brook on a couple of the open source projects Transcend is working on. And then George Rosamond will wrap our session today with a talk on privacy enhancing design. So we'll see you back in 5 minutes. I'm going to hand the mic over to Transcend's Ben Brook to spotlight a couple of open source projects that we'd love to share with the group for contribution. So Ben, over to you.
All right, thanks so much, Charles. Just sharing my screen here. Okay, so we're going to share a little bit about our open source file streaming stack for browsers. So as Kevin mentioned, we presented last month on a technology called Penumbra, which is a way of actually downloading and decrypting data on browsers. So you can download many streams in parallel, decrypt them on the browser, all using streams and on background threads so as not to block UI. So we're going to go a little bit further down this stack today. But first, I just want to share some of the motivation for why we even do this. So at Transcend, we help companies offer their users data rights. That can include things like the right of access, the right to erase one's data, opt-outs, and more. That means we transfer a lot of personal data from companies to end users. So for one user, that can include text files, photos, video files, and a lot more. For some users, this can mean there's thousands of files. And a single export can actually amount to gigabytes, which will exceed your browser's memory limits or even your hardware's memory limits. So we have to be able to do all of this through a streaming manner. As we're actually transferring this data between companies and their end users, providing that right of access, we actually end-to-end encrypt everything. So it's encrypted on the company's systems, and as Transcend is orchestrating it, we transfer it through to the end user, who is on their device, whether that's on their phone or their laptop, and we actually let them download that data right in their browser. We want this to be seamless, but decryption can be pretty challenging on this front. And so we're faced with the problem of how can we allow end users to seamlessly download and decrypt all of this data all within their browser. So when we're talking about end-to-end encryption, we face a lot of challenges where we have users trying to export their data right from the browser. And so we actually built an open sourced file streaming stack. So we're going to focus on this decryption front, which is the client-side decryption. So we're gonna kind of zoom in onto this decryption stack. So this is our open source stack. It allows anyone with a website to essentially use file streaming and perform operations such as fetching many files in parallel, decrypting them in parallel, and then actually zipping them into a single zip file and then streaming them to disk. So in our last Privacy Info event, we talked about Penumbra, which shows how to encrypt and decrypt anything in the browser using streams on background threads. This is on GitHub. This is available open source. But then we're also then sort of faced with another problem where suddenly we have all of these output streams of decrypted data. So we have these files coming through on readable streams. But how do we get that into a file on the user's disk? So when they're performing that download, how do we actually take all that streaming data and turn it into something that the user can open on their laptop or their phone? So that's what Conflux is about, and we're gonna talk a little bit about this one today. So what Conflux does is it takes in many readable streams and can perform compression on them in parallel and actually have an output stream, which is itself like a zip file. So Penumbra and Conflux were built by Transcend, and Conflux was built with an open source developer named Jimmy Warting. He is also the person who built something called Stream Saver, which allows you to take a readable stream and actually write it to disk in the browser as well. So that's what we're going to focus on is Conflux here today. So Conflux, again, as I said, it's basically streaming compression. It takes many file streams as an input and then outputs a single stream, which is one compressed zip file. From there, you can pipe it into Stream Saver, which will actually stream that zip file to disk. Conflux is a WhatWG compliant transform stream. That's just like a standards org. And let's talk a little bit about how to actually use Conflux. So here's some just sample code of actually writing a stream to a zip file. So we're going to import transcend /conflux, and we're going to set it up. So we're going to create a new writer, meaning we're actually writing a zip file. And we're going to go fetch a stream from some remote source. So in this case, we're grabbing a big 100 megabyte satellite photo of Earth. And we're fetching this and grabbing the actual file stream from it. From there, we then call writer.write. We give the file a name, and we pass the stream into it. So you can actually call writer.write as many times as you want. This could be in, for example, a loop, and you would have many files entering this sort of writer stream into Conflux as the input. And on the output, you have this readable. So we're going to show how to actually then save that stream to disk. So maybe you call writer.write many times over, and then you have, and then you're going to set up some sort of writable. So you want to read that stream and you want to write it somewhere else. So we're going to set up a file called conflux.zip. This could be my data.zip, for example. And then we're just going to stream it to disk using the native pipe2 call on browsers, which is just readable.pipe2 writable, which is the file stream. And then we're going to go ahead and close the writer. So this is a complete example of what actually writing a zip file looks like. And again, writer.write can be called many times. So there could be thousands of files and their streams being zipped. Let's talk about reading streams. So we actually also built an API to actually read a zip file and process it. For this one, we're actually just importing a separate API, which is called the Reader API. And we're going ahead and fetching a file again. In this case, it's now a zip file. And so we can go into the zip file and use Conflux to actually stream in that zip. And we're calling this a wait call. So whenever the cursor hits a file, it's going to log the entry here. And you can do whatever you want with this readable interface. And ultimately, what this did is it enabled us to offer end-to-end encryption. So not only are we fetching files from a remote destination, but we're also passing them into Penumbra to be decrypted on that background thread. Again, fully in a streaming nature. And then all of those decrypted outputs go into Conflux, which are sort of all wrapped together into this zip file, which we then stream to disk. So with that, we're able to decrypt and download any sized file or any size export. This could be gigabytes, technically it could be petabytes, but we all do that without exceeding about 10 megs in overhead on the memory because of this streaming nature. And yeah, so we encourage you to go check out Complex. It's available on GitHub on our organization's repo on transcend-io. And you can read more at transcend.io/open source. We also have a blog post discussing Penumbra, that decryption library. And we also have live examples on our GitHub repo. So here is that open source page, and please do go check it out. That's it for my short 5-minute presentation, but happy to field any questions.
Perfect. We got one question. Are there any other potential applications for this open source stack besides data portability requests?
Yeah, so virtually any sort of file drops share, for example, like you could actually build something like Dropbox or Box or any of those systems where you're actually uploading encrypted files where the user holds their own key, and it's never available to anybody else. So you're not actually trusting a third party to protect your files or anything. You have the key, and so you can upload this data through Penumbra and store it there, and then you can download it later, decrypt it client side, and then with Complex you can zip it back together. And really anything where there's data that's generated, like in the JavaScript VM, you can actually write data using this streaming stack. So for example, something off the top of my head, let's say everyone has their webcams on in like a Twitch room or something. That's data that's being generated and can be processed in the JavaScript VM, which then you can actually start just writing a stream to zip, which is just writing to your disk. So you could actually have a recording of things that are happening in the VM, and you can write that to disk. So it could be like a 2-hour-long session, and the stream would just stay open, and it would be continually writing to this. So even this like Zoom chat could be using that for the recording.
Excellent. That's all the questions we had. Thanks, Ben.
All right. Thanks so much, everyone.
Awesome. And if you're interested in contributing, you can contact Ben directly or email privacy_infra@transcend.io, and we'll go ahead and forward it through. Now to our last but not least speaker today, I want to go ahead and introduce George Rosamond, the co-founder and CTO of ClearOPS, a B2B SaaS data privacy and cybersecurity company with a vision of inspiring trust through transparency. Just as a little quick background, his first forays into the privacy enhancing community was around 2005 when he started running a Tor relay. He's been involved in the Tor project and the broader privacy technology community on a wide array of levels for a long time, from conducting workshops for non-technical vulnerable groups to running critical infrastructure and BSD Unix related development projects. So all that means is that he's the more qualified to offer some thoughts and wisdom on privacy enhancing design. So George, over to you.
Thank you very much. Everybody can hear me? Hello?
Yep.
I'm good? Okay. I just lost my screen here. Hold on. Okay. Yeah, so thank you for the intro. But yeah, I'm going to say, just to start off, a lot of what I'm coming from is a lot of experience out of where Kevin's world is out of, which is out of the kind of open source, kind of NGO projects realm. That's where I spent a lot of my time really over the past decade and a half or so on different levels, never full time, but always around that picture. So that's really my angle on this. So obviously just quick, I mean, I do like questions. I do like interactions. I do hate virtual events. I'd rather, be arguing with people face to face and so on and so forth. So, but I do like deep dives. I like to go kind of into details, which probably should be done offline. So I just really want to start off in what I've seen in this shifting environment. Today, privacy is everything. The new Apple commercial, I think everybody's seen. It's kind of part of the environment, and it's a norm. It's something that is kind of embedded into every marketing campaign and so on in a way that really wasn't true in the past. So, I mean, the great quote was, Larry Ellison's quote was, I think about 15 years ago, privacy's dead, get over it. You know, privacy, what do you have, something to hide? And then the whole, the street surveys that were taking place of, yeah, yes, I'll give you my password for a candy bar, which was an on-street experiment that was done, I think in the UK and also in New York. So just a quick history, because I think you tend to kind of like fall into the privacy, the pets community and privacy, and kind of not know the precedents that really started. A lot of it actually started around sending anonymous email. A lot of David Traum's research through the 80s, electronic voting, and had actually managed that. And then obviously Phil Zimmerman with PGP in 1991. And a lot of the beginnings really were around just research people. Then you had devs come in and start doing some implementation. And then a whole cast of characters, more like me, who are sysadmins who had experience running servers on the public internet, kind of stepped into the arena once a lot of these kind of proof of concepts became something to actually test in the real world. But yeah, it really was a focus and implementation, kind of real world, where in the early 2000s, it started to actually look at the stakes of ordinary people in this picture. There were a number of things that really set things off, though, I think, in terms of usage. But obviously WikiLeaks, the 2009 Iranian elections was a very, very, very big deal also, in terms of taking ordinary people and kind of throwing them into the whole pets universe, and obviously Edward Snowden and his disclosures. So my past, I think it was 2004 when I saw the first Tor presentation. Going back to the archives, the first relay we were running in my Unix group was in 2005. I'm kind of known, I think, in the Tor scene and beyond, kind of as the BSD Unix guy. But we did a lot of porting work with Tor browser and other software, and UX work also, a number of other things. I've done a lot of workshops. I've done, technical meetings. I've done non-technical meetings. I've done trainings. I've done the whole array of things. And that's really been, I'd say, the most satisfying stuff I've done. Actually, I'm sure Kevin could concur. I've also spent a lot of time, actually probably 10 years ago, starting, if not earlier, of trying to recruit a lot of sysadmins from my milieu to run Tor relays, to really build up operating system diversity in the network. Even started a privacy consulting firm in the summer of 2008, which, needless to say, Lehman and Bear Stearns imploding happened merely a month or 2 months after we started. So the prospects were rather dim. So now, again, I'm CTO and co-founder of a B2B SaaS firm focused on privacy and security. I still run some long-term relays that have been around for a long time, and bridges, and some critical infrastructure for Tor. But I'm really just, to be honest, at the end of the day, I don't consider myself a dev. I'm a tinkerer. I like to hack on bare metal. I like Unix, and that's most simply what I am. Now, people are a little suspicious of me sometimes because I'm not on Instagram, I'm not on Twitter, not on any of those things, because I was one of those people who was watching as these technologies were growing, and I said, I don't need the exposure. I know enough people, thanks. So I want to kind of just address the obvious, which is, what does privacy mean today? I think it's gotten harder to actually define privacy because it's really turned into something of a marketing phrase that, it's got to be, we want to make our customers confident that we're doing the right thing, that we're following our privacy policies, that our privacy policies are there to protect us. So privacy kind of used to be an afterthought, or something that, no one, apparently believed in anymore. But now it's kind of made a resurgence, especially over the past couple of years, obviously. Now, let me say the obvious design things. I mean, open source matters. It's obviously not always possible. If you're a small software project, it matters a lot. If you're a large entity like an Uber, you're going to have the devs, you're going to have the budget for Coverity and code auditing. You're going to be in a different position. Obviously, it should be open source, but end of the day, you're in a better position than a small open source project. Now, I mean, there's a lot of kind of stupid things I've seen where, like, I'll say junior devs decide they're going to write a random number generator. Things like that are obviously, bad ideas. But if you're not a cryptographer, that's not what you should be doing, just because fascinated by your abilities with JavaScript for the past 6 months. Random number generators are complex things. But then again, there's things like arc for random for those who aren't trusting what they have right now. Now, the difference, I think, especially outside of the world that Kevin and I come out of, broken pets matter. It's different, okay? We're not talking about, oh no, someone, got into my email and so on. A lot of these applications are used by a portion of the users are actually in life and death situations. That's true with, overseas trainings I've done. Obviously, when it comes to freedom of press issues, with Freedom of Press Foundations dealing with, and so on. And you're dealing with a whole variety of adversaries. Obviously, three-letter government agencies are big, but also the issue with doxing today. Doxing is a very big deal. But also people who need privacy and anonymity are, people who are victims of domestic violence. People tend to think of these kind of big glamorous spy scenarios when actually privacy and anonymity are really base needs from a whole layer of people who are frequently ignored. And obviously it changes when it comes to data breaches, right? It's not just a breach or a vulnerability and it's bad and hopefully you'll patch it in the next 6 months before an adversary finds it. Pets tend to be applications in particular are targeted and focused. Everybody, look through every year, look through the DEF CON agenda. Find me 2 or 3 people who aren't trying to make their name by how they broke Tor. That's part of the game. So I want to kind of take a step back to what was true, say, 10 years ago, which was what I used to call the Holy Troika, or the Holy Trinity. It used to be Tor, PGP, and TrueCrypt. Everyone's familiar with all 3 of those, I assume? I'll assume that's all a yes. But these were really the 3 core applications everybody was focused on, especially in terms of trainings, in terms of documentation, and actually in terms of implementing user interfaces for. But there was a problem. TrueCrypt actually was deprecated, died an ugly death, and very much was in a situation where no one noticed, really, that this software, which had become part of the kind of core of everything, had actually been deprecated, was full of holes now, and a lot of people were relying on it. And this was really one of the problems. And this is a general problem, I think, overall when it comes to pets. A lot of workshops and trainings in particular focus on teaching tools. They teach things, where it requires user to patch, developers to patch and update. And but ultimately, most of them go to SourceForge to die. There really needs to be more of a focus on tool teaching, not on tool teaching, but rather threat modeling, methods, and then really letting the users really come down to what they need. I think when you have a narrow case like SecureDrop, which I'll use an example, it's obviously a different situation. Because right now you have currently a well-supported application that's well known. It's a bit of a complex implementation, but end of the day, it's not just something being cast out there for the broad audience. It's used by a very specific audience, and you're assuming that they're staying on top of it. Now, the kind of the phrase that kind of is driving me a little crazy over the past couple of years has been hearing privacy by design, security by design, blah, blah, blah. And that term actually does have an origin with that with the minister from Ontario early on, but it was quickly adopted by the Tor project. It's not saying in your policy, we do things by design. We do privacy by design. We promise you, we're assuring you. That really isn't by design. That's by promise. That's really not a verifiable, observable issue. And obviously, for me, people in my world, it was always the privacy policies were really just long legal documents that even if I found holes in, even if I found ways to sue someone, the EFF could never fund me to take on these legions of lawyers that the Yahoos and the Googles have of the world. But again, privacy isn't really just about protecting PII, personally identified information. If you're not even maintaining PII, data breaches might seem to matter actually less. But actually, what is PII? I know there's a debate between the California law, CCPA, and GDPR about what is considered PII. Is IP addresses considered PII? But obviously, in practice, IP addresses are PII if you have a state actor who's actually watching your network traffic, right? For all intents and purposes, our criteria for PII is a lot higher than what a HIPAA or a GDPR will talk about. But obviously, in a lot of cases, it's not even that PETS applications are collecting PII as much as they're transporting and storing PII. Now, I think, again, I'm going to be Tor heavy here because I think, not just because I've been around the Tor scene for a very, very long time, but also I think Tor is really a canonical example of what a privacy by design solution is. It's obviously a different context. It's a public network, and it's been around a long time, and it comes out of research from the 90s and blah, 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 but it still really sits as the gold standard to me. I guess I'm assuming everybody kind of knows what Tor is. Essentially, 7,000 relays providing 3-hop circuits, really from the intent of initially just really focus on anonymity, hiding the source IP address identity over TCP networks, an overlay network on the internet. But the by design part is that there's really very little trust necessary in the Tor network. You'll hear people rant about, oh my God, you know, this 3-letter government agency runs a lot of relays, or that evil nefarious force does it. And you know what? That's kind of assumed. It's assumed that, you know, 2 rival countries, both of them are running relays and trying to read each other's traffic and trying to capture each other's traffic out of their embassies or whatever the context. That's built into it. You know, the idea is that the 3-hop circuit and it changing every 10 minutes puts us in a situation where we're minimizing it. That's why the role of volunteers like myself running relays is all the more important. And also actually building out the Tor community. The assumption is that you don't trust anyone. And that's what we really mean by design. I would contrast that to a lot of VPN services that people are using for privacy and anonymity. End of the day, it's often the first option people look at when they want to evade censorship and circumvent censorship or get some degree of anonymity online. But at the end of the day, it really turns into a single point of a funnel for all your traffic. And it's really qualified data. I mean, I'm a VPN service provider. All my users I know are trying to evade something. They're trying to do something that they don't want other people to know about. And it's actually better than having every user who's on Verizon Fios or anything like that. It's a much more qualified audience from the marketing perspective, I'd say. And a lot of it is, again, based on promises. You know, we don't log. You know, they're not throwing spyware on my computer. And we don't really know that. There's really no way to verify that with VPN solutions. Now, this is really the kind of grand case. There was a whole proliferation in the late 2000s of solutions that specifically marketed to the Chinese audience of people trying to bypass the Great Firewall of China. Now, the ironic thing is that not only were they technically very poor solutions, their usage base was enormous, but they were also selling, and you can see it on a few of their websites when their sites were live in 2009 and in 2010, that they're actually reselling quote unquote anonymized user data. I mean, that was almost nice because they were admitting it. In most cases, they're not admitting it. They could say they're not collecting logs, but unless you actually have root on their boxes, how do you know that? You know, how do you know there isn't another device in between or afterwards looking at traffic, reporting man-in-the-middle attacks, and so on and so forth? You don't. Just personally, and I would say you always have to think like the adversary when it comes to privacy. You know, I would, if I had a big budget and I was a 3-letter government agency and I was trying to monitor citizens in my country, I would create a great marketing campaign for a tool. I would make it technically robust. I would target hard in the most basic ways. I would use that data, and I wouldn't resell it because I'd be interested in surveillance, and no one would know for the worse. I would never resell it because I would just throw my cards on the table. I'd rather be known as a verified, trustable provider that everybody wants to use and actually collect user data, and you wouldn't know. Now, another kind of issue really when it comes to network level is there's always a problem of kind of single points of failure in general scenarios. This is, again, something that really is tied more to network-based solutions, but you're looking at, you know, bigger diversity on whole numbers of level. You're looking at the geographic, the ASNs and the pairing arrangements and so on and so forth, and also operating systems. There's some major problems with the Tor network in terms of monoculture, which I've actually been part of the project that actually adjusted that a bit, which is, you know, 93%, 92% and a half at this today of Tor relays are actually Linux boxes using the same kernel, same TCP/IP stack, and a lot of them are using OpenSSL, which if you want to go back to the whole OpenSSL debacles of the past few years, you can kind of get a sense of the dangers of that. So, I mean, I think Roche mentioned earlier, you have to make privacy easy. And I can't emphasize that anymore. People from my world, kind of like hands-on sysadmins, are not, don't have the mentality. I want to run Tor browser and see TCP dumps in a side window as things are going on. I want to know if my DNS lookups, are encrypted, or, what's happening that the remote website's doing. Users don't need that. And for a long time, UX, user experience, really was an afterthought. We saw that change, I think, really in 2015 and earlier. I myself was part of a UX project study, usability testing on Tor browser in 2011 or 2012. And it was really around that time things started to change. And it really matters 10 times more when you're looking at an anonymity solution. Because anonymity, requires crowds. You can't have an anonymity solution for two people. If you want anonymity, you have to build a solution where those two people are lost in a very, very large universe. And you can't have a large universe if onboarding is difficult. It's an inherent issue when it comes to it. And actually, I think the nice thing is that PETS elevates UX to really the place it deserves to be. Now, I keep talking about anonymity. I'm kind of throwing it in there without explaining. I actually think that it's not the same as privacy. If everybody says, security is not about obscurity, well, actually, anonymity is all about obscurity. It's being obscured and lost in the crowd. De-identification. And there's obviously overlaps and interrelation between privacy and anonymity. But most importantly, you could think of the example, which a lot of three-letter government agencies are interested in, where, they don't really care what the content of the conversation is. They just want to know who talked for when, for how long. And that's actually the data they're most concerned with, the metadata of the picture. That's why anonymity actually fits into the picture as a fundamental part of most privacy solutions. Now, that's the problem, is that a lot of times we've seen a lot of big corporations are doing massive data mining, are really, they'll talk about privacy, but they won't people worried about anonymity and de-identification. They're really, to be blunt, they're really concerned about protecting the data between their users, their quote unquote users, and them, and from their competitors and from nefarious third parties. It's not about actually protecting the identity and the anonymity for that user. Obviously, all the providers that were going, oh, we need your cell phone number for 2FA, two-factor auth, even though NIST explicitly said this was a bad idea, right? SMS is a bad idea for 2FA. And then, I have to get lots of JavaScript from your application, which knows all the fonts I have on my PC. It knows every little detail of, my screen size and so my mouse movements and so on. But also when it comes to anonymity, I think SecureDrop in many ways had the right approach, because it was looking for pseudonymity. It was looking to maintain a constant identity that was hidden, but it was a constant identity of persistence. Oops, I just hit last. Sorry. Let me go. Oops. Sorry. If I had nicer fingers, this would be easier. With their anonymity. Okay. So, and if you actually look at it, anonymity is really a core question to be adjusting. Now, I'm going to be Tor heavy here, and I'll just be clear. It's, there are lots of use cases where you need to give anonymity to your users. You might not think for every case where someone has a persistent, for their bank account access or filing their taxes and so on and so forth. But I actually do think there's a lot of cases. Now, if you go to CNBC doesn't want you as a Tor user visiting the site. And you might go, okay, that's their right. Maybe they're getting a tax over the Tor network or whatever else. But, why do they need to know who I am coming to their site? But then the IRS also blocks Tor. And, okay, well, I just want a tax form. I'm not submitting my taxes. What if I just want a tax form? You're still blocking me over Tor from getting my tax forms. But then you come to a context where you have healthcare sites, and this is actually one of the important uses for Tor. Can you think of instances when you'd want anonymity when dealing with healthcare questions? Do you want your insurance company to drop you because you're worried about you might have cancer? You could think of whole hosts of issues, and forget about the big picture. Think about the team. Who's looking for an abortion? you know, who's looking for basic reproductive services that doesn't want their conservative parents to know about it. Anonymity is actually really important when it comes to healthcare issues and services. But I think this is the case in point, which kind of is annoying. Is Startpage is a search engine that purports to be, you know, privacy based and supporting anonymity, and it shouldn't really cause me an issue if I'm hitting it from Tor. It should actually be assumed. The Tor public exit IP addresses are public. You should know, and let's go from there. I've never heard that they've actually approached anybody from the Tor project to deal with it, but it is actually an interesting case in point. Thank you for being focused on privacy, but if that's your words, and I appreciate your words, and I you know, will embrace them, but if you want to prove it to me, let me hit your site through Tor. Sorry. Okay, so again, it's like you're not allowing anonymity by design if you don't let Tor users visit your site in the first place, or if you require any like heavy client-side scripting like JavaScript. And most importantly, I think what you're seeing today is an increased use of Tor and Onion sites, the quote-unquote darknet, because it's about access. A cookie for anyone who guessed the biggest website on the .onion world, on the darknet, quote-unquote. It's Facebook. And it is also the most populated site on the dark web and so on and so forth. But I want to go back to like design issues because specifically, I mean, I'm a Unix guy by trade. I come out of BSD community, OpenBSD, FreeBSD projects. And I think a lot of the old rules of Unix remain the same. You know, building for modularity. There's a problem when you're building a big, you know, a whole operation and you can't actually swap parts out. When, you know, you want to use OpenSSL, but I want to use LibreSSL or Boring SSL or GNU TLS or whatever your alternatives are. When you're building it and actually tying your pieces together so tightly that you can't swap them out, it gives you a problem with interoperability with other users. It gives you a problem specifically, I also think, with dealing with compromises and changes in software. But I think, I mean, the main Unix principle people have always talked about is really one tool for one task. Don't build something that's big and bloated that does everything for everybody for all the problems they face today. I would say until recently, this was really, I mean, GNU PG is unfortunately a great example of it. If a user wanted to verify that the digital signature of a Tor browser download, they had to download PGP, install it, and then run one line command to check the digital signature against the Tor public signature. Well, just to check a digital signature, I need to load this monstrosity of 100,000 lines of code. I mean, we've got to look towards, you know, tighter, clear, single-purpose use solutions that actually fulfill it. I mean, OpenBSD has Signify, Signify. I know there's another solution that people in Linux world do, which is great. I mean, and that's where we have to move. We have to move to smaller tools that actually play nice together. Not large bloated pieces of furniture that are actually, I'd say, difficult to maneuver, upgrade, and change. Now, I'm going to hit on the Unix thing a little harder here just because it's a pet peeve of mine. I know this isn't relevant for everybody because a lot of people are living exclusively in the cloud today. But I mean, what I see a lot, and especially in terms of the open source stuff, is a lot of things, you know, tests and install scripts are written in shell. Now, shell doesn't mean bash for the Unix people out there. I hope everybody gets that. Bash is really a kind of, you know, is one of many shells. It's also the most bloated. And when it comes to portability, you're also causing a problem because I think OS X now uses Z shell, and none of the BSDs have bash by default. But go to miner.org, look at bash vulnerabilities. I mean, bash has had more vulnerabilities as a shell than a lot of like network security applications, I would say at this point. I don't want open network sockets. I don't want you know, complexity. I want standard basic shell because I'm running tests. You know, shell is glue. Shell isn't, you know, an application into itself. It's a glue to use that should work across platforms. So that's really that's a little, I'd say, a pet peeve of mine. I just wanted to note. Now, it kind of comes down also to and especially, I mean, this goes on in large corporations, obviously, but also especially in the grant-funded scene that I'm sure Kevin's familiar with, and every kind of open source software project that's working with grants. You're really paying people to write more code. That's what the funders want. People are looking for features. But again, the standard security rule of all times is always more code means more bugs. And I'm not going to take a swipe at Qubes here directly, but end of the day, when you're looking at solutions that are based on abstractions, like more virtualization, cloud solutions, and so on, you're really looking at a lot more lines of code that have to be accounted for, that are, possible surface area when it comes to vulnerabilities and attack, and more software to worry about. And people really should spend more time deprecating old code. I think OpenSSL, when there were the major forks a few years ago with the vulnerabilities, there was still support for like Windows 3.11 and VAX, and I mean, it was out of hand. That's why the OpenSSL, really an unmaintainable project. I mean, I could say specifically with Libre SSL, the OpenBSD people did, that's been adopted pretty widely at this point. I mean, they spent the first few months just ripping code out. Let's decrease the surface area. But also going back to the shell issue, portability actually cuts down the code. If I don't have Bash on my computer and I need to run your test scripts and I have to install Bash because you wrote your script specifically in Bash, that's a problem. Now I have to install a new dependency of Bash. Obviously, small footprints are less likely to step on broken glass. That should be obvious. We've got to spend less time or as much time writing code as deprecating code out and replacing and tightening code. Now, I want to kind of take one quick thing, though, because I've watched the way privacy went from being something that a lot of large corporations joked about and said that no one cares anymore, and to something where it's kind of it's a bumper sticker that's on every car today. It's really kind of ironic to watch it because, frankly, if your business is data mining, you should really need to reassess twice what you're talking about when you're talking about enhancing privacy for the users. You're probably just talking about, making sure you have control over your users' data as if it's your own and not an adversary. So I would kind of wrap it up here, but I think the grand list of research papers on anonymity is on Freehaven, which has been maintained for a very long time, and you'll see it by the web design. There's a fuller list, but this is probably the golden list to follow. You could find the early, David Chom papers. You could find stuff on Mixnets, Mixmaster, and so on and so forth, and a lot of other things. Those are the two different onion addresses. You'll see one is the old version, the short one. One is the new, which is longer, which if anybody knows about Zuko's Triangle, they'll realize it's been broken by onion addresses. That bad VPNs piece, which again is dated, it came out of Hal Roberts at Harvard. And I'll end it there. Hopefully I was brief and tight enough, and I didn't lose anybody in the process. And I see there's a lot of questions. Wow. But I'm actually interested if anybody's interested, maybe arranging something in the future, next couple of weeks, to do more of a deep dive on maybe some of the issues I brushed over.
Excellent, George. We'll make sure to follow up on that. We do have some questions coming in. I'll go ahead and just fire them away to you. Do you think the confusion and muddling of privacy, anonymity, and security is intentional, or the result of us not being more deliberate about taxonomy, or is it possible to undo it?
Oh God, that's I don't know. If you have the answer, let me know. Let's talk privately though, not make it public. In all seriousness, I think some of it was self-justifying, and it became just kind of a version of security for everyone. I do think it was interesting when I first came around the kind of open source scene around pets. It was really circumvention. It was really getting around censorship. It wasn't anonymity. It wasn't privacy. And a lot of big corporations will sit there and fund things that are privacy related. But end of the day, people, when you're talking about anonymity, it becomes scary. So I do think there's a little bit of a self-serving part of it. I also, though, think that there's still a misunderstanding about how critical that anonymity and data identification is to privacy solutions in general, to pets. But I think that's a great question. That's someone who's following the the theme here.
Second question, crystal ball, what is privacy going to look like for web users in 10, 15 years? What lessons here are we most likely to adopt, and what will get missed?
You know, it's funny because I last night I kind of was going back to one of the old like tomes of privacy, which was the Diffie Whitman and Susan Landau's book on privacy on the line. And I was on page 271. There's a quote about anonymity, and it was, you know, in the late 90s, and it's like, well, if your IP address changes, you know, you're in good shape for monitoring. You know, you're really not going to have an issue with surveillance. You know, so make sure your IP address is changing a lot with your provider on your dial-up or whatever. And then actually a close friend of mine who is at a major company that does online marketing, data mining, and so on. You know, 10 years ago, it was too expensive to sit there and do heavy, deep down de-identification of customers on the web browser side. You know, it was like if it was an IP address, they couldn't track it. It was, and username, it was too much. They couldn't sit there and look at the dimensions of your web browser. You know, for every web browser, now they're tying things between identities, between devices, and so on. In 10 years, I don't know, because I didn't imagine we'd be here today now. From 10 years ago, I never imagined. I think it's a hard question, and I mean, I could sit there and say pontificate over drinks on that, but I honestly, I'm always afraid in privacy of what's going to happen in the next 5 years, and that's been true since the beginning for me.
Cool, awesome. Well, end with this one. Are there any recent privacy-enhancing technologies you're excited about?
You know, it's tough because I think, I mean, there's some discussions going on right now in some of the privacy communities I'm in, where the kind of, I'd say the models that we've been working with, the paradigms of the past are changing. You know, you see funny things on a day-to-day basis where high school students, you know, they left Facebook to go to Instagram because they thought it was more private. Now, forget about the merits of it. I think there's something in there. You need to think about usability more. I know that, you know, especially Roche, you know, put heavy emphasis on that, on the consent issue. But I think, I mean, there is some experimental stuff coming out of Germany right now with some, you know, kind of mixed networks again, which is the kind of common theme going back to the 80s that Tor fits into, and also Java and I2P and so on. There is some cool stuff. It's in development. The repositories are public and online and all Go stuff. But no, I'm not. I mean, I think the most enthusing thing to me isn't even technical. It's the fact that there's an about face. And I think really going back to Snowden especially, really blew it open in terms of what the world is really like. That it is actually quite nefarious from all levels.
Cool.
And that recognition is vital.
Awesome. Well, thanks, George. We're coming up on time. Really appreciate your talk today.
Thank you. Thank you.
Awesome. Great. So before I hand it back to Ben to close us out today, I want to give a quick heads up to our next Privacy Infra event, which will take place actually on Thursday, November 12th. So 2 speakers to highlight, one from Snap Inc. and Snapchat, privacy engineer Danuja Shaj, and from Privitar, principal architect Brad Schoening, who will also be joining us for that time. And registration actually is now open for that event. So go ahead and just head to transcend.io/privacy_infra and hit register for November.
Yeah, thank you all to our amazing speakers today, and to everyone for coming to our Privacy Infra event. We'll send an email out early next week with a link to the recording so you can watch back specific talks. You'll also see a quick survey when you exit the webinar, which we'd be grateful if you'd complete. And a reminder, if you'd like to speak at our next event, or even just make a suggestion for a topic, you can email us at privacy_infra@transcend.io. And with that, have a great rest of your day, everyone, and we'll see you again in November.